Hello everyone, and welcome to our week 3 video. We are covering a lot of material this week, so I'd like to get started right away. I will be covering the following topics in Python: if statements, also known as conditionals. I will also cover collection data types in more details today, so I will be talking about lists, dictionaries, and tuples. And I will also cover functions and the new week 3 module material. So it's a loaded week, and this will be a relatively long video. Alright, so first let's discuss the topic of conditionals, which is better known in the programming world as if statements. But before I start, I want you to pay close attention to this image on the right. The caption reads, "A Python developer measuring the level of indentation." So, in most programming languages, indenting your code is optional and is only done to make the code look more organized and readable. So it's for cosmetic purposes, really. But in Python, indentation is a way of telling a Python interpreter that a group of statements belongs to a particular block of code. And a block is a combination of all these statements and can be regarded as the grouping of statements for a specific purpose. Now, while most programming languages like C, C++, and Java use the braces or the squiggly brackets to define a block of code, Python uses indentation to highlight the block of code, and whitespace is used for indentation in Python. So all statements with the same distance to the right belong to the same block of code, and if a block has to be more deeply nested, it is simply indented further to the right. So when I first started to play with Python code, I fell into the indentation trap. I thought that my code was properly indented, but my code was not behaving as expected. So, just like the picture on this slide here, I would measure the spaces of my indented code to help troubleshoot the problem. There is some humor to it, but at times it can be very frustrating as well. I guess it's a rite of passage for any new Python developer to experience this pitfall, at least once. In Python, conditional statements control the flow of a program by executing different blocks of code based on certain conditions. And here are the different types of conditional statements. The simplest form is the if statement, which runs a block of code only if a specified condition is true. If the condition is false, then the block is skipped. Next, we have the if-else statement, which extends the regular if statement by providing an alternative block of code to run if the condition is false. This ensures that one of the two possible code blocks will always execute. Then, for more complex decision making, the if-elif else statement is used. This structure allows for multiple conditions to be checked in sequence, and the program executes the first true condition block it encounters and ignores the rest. But if none of the conditions are true, then the else block runs. Alright, let's move on to the next type of if statement, which is the nested if statement. Now in Python, nested if statements are used when you need to check additional conditions within an already established condition, which creates layers of decision making within the code. And lastly, Python 3.10 introduced the match case statement, which is similar to switch case constructs in other programming languages. It allows for pattern matching, providing a clear and concise way to handle multiple possible values of an expression, each with its own corresponding block of code to execute. Now this is particularly useful for more complex decision-making scenarios where a variable might match one of several specific patterns. And we will see examples of these if statements very soon. Alright, this slide illustrates the basic structure and flow of an if statement in Python. First of all, we start with the reserved word if, followed by some condition, then followed by a colon. So the if statement is used to execute a block of code only if a specified condition, represented here by the expression, evaluates to true. So this flowchart is presented to visually explain the decision-making process of an if statement. If the condition expression evaluates to true, the program executes the block of statements indented within the if statement. These statements are executed sequentially, as indicated by the green arrow pointing from one statement to the next. Once all the statements with the if block have been executed, then the program continues with the following statement outside the if block. Now, if the condition evaluates to false, the program skips the entire block of statements inside the if statement and directly proceeds to the following statement, as indicated by the red arrow bypassing the block of code. So see how indentation is important? The block of code that will run should the if statement condition be true, that block of code is grouped together by being indented on the same level. So again, indentation is very important in Python. This slide explains the structure and logic of an if-else statement in Python. The if-else statement is used to execute one block of code if a specified condition is true and another block of code if the condition is false. The diagram here presents the syntax and flow of an if-else statement. It begins with the if keyword, followed by the condition expression. If this condition evaluates to true, then the statements within the if block, which is the indented code under the if expression, are executed. But if the condition evaluates to false, then the program follows the red arrow to the else block. Now the else block contains its own set of indented statements, which are executed when the condition is false. Now this slide also visually emphasizes the binary decision-making process. Either the statements within the if block executes, which in this case the condition is true, or the statements within the else block executes, in this case which the condition is false. And after executing the appropriate block of code, the program continues with the rest of the code that follows the if-else statement. Now this ensures that one of the two code paths is always taken, which provides a clear way to handle different outcomes based on a condition. Now this slide provides a detailed explanation of the if, elif, else statement in Python, which is a more complex conditional structure used to evaluate multiple conditions in sequence. The slide illustrates the syntax and flow of the if, elif, else statement. So it starts with the if keyword, followed by the first condition, cond1. Now if cond1 is true, then the code block under this if statement is executed. But if cond1 is false, then the program moves to the elif keyword, which is short for else if, to evaluate the next condition, which is cond2. Now if cond2 is true, then the corresponding code block runs, and if it's false, the program checks the next elif condition, which is cond3. Now this process continues for as many elif conditions as needed, and if none of the if or elif conditions are true, then the program executes the code block under the else statement. So this slide highlights several key points. Each if and elif condition is evaluated in sequence. The first true condition block is executed, and no further conditions are checked, so we exit the if statement altogether. But if no conditions are true, then the else block runs, if one exists, because it is optional. And please note the indentation presented by the tab. That is very crucial again in Python to denote the blocks of code belonging to each condition. Now the diagram uses color coding as well and arrows to clearly show the flow. So the red arrows on blocks denote the if condition. The blue or more like purple arrows on blocks represent the elif conditions, and the green arrows and blocks indicate the else condition. So this visual representation emphasizes the sequential nature of condition checking and ensures only one block of code runs, providing an effective way to handle multiple possible outcomes based on various conditions. Okay, this slide is about an exciting new feature that was introduced in Python 3.10, and it's called the match case statement. Now this addition is part of PEP 622 and brings a powerful pattern matching syntax to Python. And in case you're not familiar with PEPs, they stand for Python Enhancement Protocols. A PEP is basically a design document providing information to the Python community or describing a new feature for Python or its processes or environment. So anytime a change is suggested to Python, a PEP is created, then it's reviewed, and then either accepted or rejected. Now the match case statement is designed to provide a more readable and concise way to handle conditional logic. If you're familiar with switch case statements from other programming languages, you'll find this concept quite similar, but with additional flexibility and power. So let's look at a basic example to understand the syntax. In this snippet on the right, we have a variable named status that we're matching against several cases. Here the match keyword is followed by the variable status. We then have multiple case clauses that check for specific values for this variable. Also notice in the second case statement how we use the pipe operator to match multiple values in a single case. This basically says that if we match a case that is of a value 301 or 302, then we execute the indented code just below it. Now some of you might wonder why use match case instead of the traditional if, elif, else chains. Well, first, it significantly improves the readability and maintainability. The syntax is cleaner and it's easier to follow, especially when dealing with multiple conditions. Also, it provides more expressive pattern matching capabilities, which can simplify the handling of complex conditional logic. And match case is particularly useful in various real-world applications. For instance, it can handle different types of HTTP status codes, as shown in our example. It's also great for parsing and processing structured data like JSON and XML, and for implementing state machines or decision trees. So we can say that match case statement is a significant addition to Python, making our code more readable and our logic more expressive. I certainly encourage you to experiment with match case in your projects and explore its full potential. And for more advanced usage and examples, be sure to check the official Python documentation. Okay, next we have nested if statements. So in Python, nested if statements allow us to evaluate multiple conditions within each other, giving us fine-grained control over the flow of our programs. Alright, so let's break down the structure of a nested if statement, as illustrated on this slide. We start with a parent if condition. This is our initial condition that we check using the if keyword, and as you know by now, in Python, after declaring an if statement, we must follow it with a colon. Now the colon indicates that the next indented block of code belongs to this if statement. And inside the block of code for the parent if statement, we can have another if statement. This is known as the nested if statement. And just like the parent if, it also ends with a colon, and the code inside it must be indented. So here we have if condition, colon, followed by a nested if condition, colon, then two statements. So this shows that statement 1 and statement 2 will execute only if both conditions are true. We can also have an else clause associated with our if statements, and the else clause provides an alternative block of code that runs when the if condition evaluates to false. For the parent if statement, we can add else, colon, then statement 3 and 4, and this means if the initial if condition is false, the code block under the else will execute instead, so running statement 3 and 4. And it's in these more complex nested if statements that indentation become very visible and crucial. Now the obvious reasons is because it defines the scope of each block of statements. Every if and nested if statement must have its own associated block of code, indented properly, or else the behavior will not be as expected. So to recap, the flow of our nested if statement can be visualized like this. If the parent condition is true, then check the nested if condition. And if that's true, then execute statement 1 and statement 2. But if false, then the code under the else statement will run. But if the parent condition is false, then we execute statement 3 and statement 4 under the else block. So the nested if statement structure helps us to efficiently create complex decision-making processes in our code. Alright, on this slide we have a series of Python code snippets that demonstrates the use of conditional statements. We begin with a variable x set to 5, and our first condition checks if x is equal to 5. Now since x is 5, this condition is true, and so we execute the indented code and print the string equals 5. Next, we evaluate whether x is greater than 4, and as x is indeed greater than 4, then this condition answers to true, so the program prints greater than 4. Following this, we have a condition that combines two comparisons using the OR operator. It checks if x is either greater than or equal to 5. Since x is equal to 5, we execute the indented code and the output will be the string greater than or equals 5. We then check if x is less than 6, which is true, so it prints less than 6. Similarly, when we check if x is less than or equal to 5, it also prints a message as the condition is met. And lastly, we have an inequality check to see if x does not equal to 6. Since x is 5, then the condition is true, and so we execute the indented code and the program prints not equal to 6. So these examples highlight how conditional statements can direct the flow of our program based on various conditions. Again, they are an essential tool for decision-making in coding. So far, most of our if statements have just been about one condition, but in real life, the concept of multiple conditions does exist. And so we need to translate that in programming as well. and this slide presents two distinct ways to combine conditions into a single if statements. First, we have the all or nothing approach. This is represented by the code snippet if condition 1 and condition 2 and condition 3 : In this scenario, all conditions must be true for the indented code block to execute. It's like a series of locked doors, where every key must fit in order to open the way forward. So only if condition 1 is true, and condition 2 is true, and condition 3 is true, only then can we process the indented code. Next, we look at the only one method. Here the code reads if condition 1 or condition 2 or condition 3 : Now this is more flexible, as only one condition needs to be true for the action to take place. Think of it as multiple paths where finding just one open route allows you to proceed. So if any of these conditions is true and the other two are false, we still execute the indented code. Again, these conditional structures are fundamental in programming, and they allow us to control the flow of our code with precision and logic. Alright, now in programming, it's inevitable for things to fail, and we encounter errors. The key is to anticipate such errors ahead of time and know how to handle them gracefully in your code. The last thing you want your code to do is crash and display a cryptic message or an error-filled screen that confuses your users, right? So think of it like this. Imagine you're navigating through a maze with potential traps. In programming, these traps are errors that can occur during execution. And to safely navigate through this, we use what is called the try-except structure as our guide. Now I'm bringing this discussion up with the if statements because it's very similar, as you will soon see in the coming slides. So let's delve into the material on this slide first. We start by wrapping up a section of code with the try keyword. This is the part of our code that might trigger an error, much like a step that could spring a trap. Now if the code within the try block executes without any hiccups, then the program will continue as normal, bypassing the execute block. It's as if we've stepped over a trap without triggering it. However, should an error actually occur, then the flow of execution immediately shifts to the except block. This is our safety net, allowing us to handle the error gracefully. And whether it's logging the error or providing a user-friendly message or attempting a recovery process, the except block ensures our program can continue running or terminate safely. So by effectively using the try-except structure, we can prevent our programs from crashing unexpectedly and provide a more reliable experience for the user. Now remember, error handling isn't just about avoiding crashes, it's about creating a seamless and professional user experience. So again, in programming, we often encounter situations where our code might run into errors. These could be due to unexpected user input, unavailable resources, or simply bugs in our code. And to ensure our programs can handle such situations gracefully, we use the try-except structure. In the try block, you see the statements or code we want to execute. This is where we put our initial attempts at running a piece of code that might raise an error. It's like walking on a tightrope while being unsure if it can hold your weight. Now, what happens if our code encounters an error? Well, that's where the except block comes in. If any statement within the try block causes an error, the flow of execution immediately moves to the except block. Here, we can handle the error, we can log it, or take corrective action without stopping the program abruptly. So for example, if we try opening a file that doesn't exist, the try block will raise a file not found error. But instead of crashing, our program will jump to the except block where we can inform the user about the issue and perhaps ask them to provide a different file path. So in summary, the try-except structure is like a safety net for our programs. It allows us to catch errors, deal with them effectively, and continue running our program smoothly. Now there's more to try and accept than just these two words. We also have else and finally. But let's begin at the very top again with the try block. This is where we place the code that might cause an error. It's our first attempt at executing something risky, like opening a file or connecting to a database. Now, if everything goes smoothly, the program will continue past the try block without any issues. But what if it doesn't? What if an error occurs? And that's where the except block comes into play. If an error arises in the try block, the program immediately jumps to the except block. Here we can handle the error, log it, or take some sort of a corrective action. It's our safety net, ensuring that our program can deal with unexpected situations without crashing. But in addition to try and except, we also have the else block, which runs only if no errors were encountered in the try block. It's like a reward for when things go right. So if the try block does not generate an error, then we go to the else block. And lastly, we have the finally block. This block will execute no matter what. So whether an error occurred or not, the indented code in the finally block will run. It's typically used for cleaning up resources like closing files or releasing connections. So together, these blocks form the try except statement, providing a structured way to handle errors and maintain control over our program's flow. It's an essential part of writing clean, reliable, and user-friendly Python code. And as a programmer, you need to become familiar with this approach. So you need to anticipate any errors ahead of time, place your risky code in a try block, and handle any potential errors gracefully using the combined use of the except, else, and finally blocks. Alright, I'm going to switch gear now and start talking about collections. So by now we are familiar with variables and how they are memory addresses which hold values of single items. But what happens when we want to have a variable that stores multiple values at once as one variable? Well, this is where we introduce the concept of a collection. Now think of a variable as a storage for single value items, while a collection is a storage for multiple value items. And so lists is one example of a collection. And in Python, there are three other types of collections. They are dictionaries, tuples, and sets. I will discuss dictionaries and tuples today after we're done with lists. And to define a list, you simply give it a name as with any other variable, but we follow it with square brackets, and inside these brackets, we place the different values of our data. So, as the name implies, it's a list of values. For example, you want to store the names of students, or the names of fruits, or the names of the 7 days of the week. Well, you can store them in a list. And here we have an example of a list of fruits. The variable's name is called fruits, and is set to equal a list of different fruits. Now, how do I know this is a list? Well, it's a collection of items, and in this case they are apple, banana, and cherry, and they are surrounded by square brackets, which indicate that this is a list. And the last line here shows how to create an empty list. If we just set a variable to empty brackets, then that's an empty list. And we can also create an empty list by using the list function, which is a built-in function in Python. Well, why do we need to have lists? The short answer is that there are business requirements at times that would benefit from having a list versus a group of separate individual variables. And having a list means we have items in the list. These items have attributes, for example, they are indexed. This means we can reach these items or call these individual items in the list by their index location. For example, if an item is the first in the list and I need to call it, then I would call index number 0 of my list, because indexes are always 0 based. We will see an example of this in just a few moments. List items are also ordered, meaning that they are in order, but the good news is that we can also change that order. When you are working with lists, the list items can be changed, like changing their order, but we can also change the value of the items. We can add an item, and we can delete an item in the list. In programming terms, we call this mutable, which means changeable. Another attribute of lists is that the items can be duplicated. So if you have a list of numbers or words, any of these numbers or words can be duplicated. Some other collection types do not allow such flexibility, as we will soon see. Also, the items don't need to be of the same data type. For example, one list can hold items that are a mix of strings, integers, and booleans. So we don't have to have a list that is all strings only or all integers only. And last but not least, lists come with a decent number of methods. These methods allow us to perform certain operations on our lists, and I will go through them one by one in my demo today, so you will become familiar with all of them. Okay, so I just talked about lists, and I said that they are one of our 4 collection data types, and this meant that one single variable can hold multiple values. And so dictionaries and tuples are 2 more of these collection types, and I'll start talking about dictionaries first, then I'll move on to tuples. So just like lists, dictionaries can also store multiple values in one variable. But one key difference is that instead of the square brackets used with lists, dictionaries use braces, or sometimes they're referred to as squiggly brackets or curly brackets. And you can see an example here of what a dictionary looks like. Inside the braces, we have some data, and I'll explain that in a moment. Then right under that, we have an example of what an empty dictionary might look like. We can also declare or initialize an empty dictionary by using the built-in function dict with no arguments, so just empty parentheses. Now, the main distinction of dictionaries is that they use something called key-value pairs. And perhaps the best example to illustrate this concept is just a regular English dictionary. Our regular dictionary has words, and each word has a definition, right? So this word and definition pairing logic is the foundation of dictionaries in programming. But instead of word and definition pair, in programming, we call it key and value pair. So as you can see in this example here, I have a dictionary called cars, which contains 3 key value pairs. The first key is brand, and its value is Ford. Then I have another key that's called model, with a value of Mustang. And finally, a third key, which is called year, with a value of 1964. So this is what I mean by a key value pair. And we separate the key and value by a colon, while the different key value pairs are separated from other pairs by a comma. Now, similar to lists, dictionaries are also ordered, which means they have a defined order of items, but this wasn't always the case, and prior to Python 3.7, dictionaries were not ordered. Another thing about dictionaries is that they're also changeable, meaning that we can update, add, or remove items after the dictionary has been created. However, dictionaries cannot contain duplicate keys, so no 2 items can have the same key name. For example, if you look at my cars dictionary up here again, if I add another item with a key called year and give it a value of 2023, then when I call the year key, Python will ignore the first key value pair and retrieve the second one. So while it's possible to have duplicates, Python will only retrieve the last one. And dictionaries come with a decent number of methods to help us work with them in a more efficient way. You might remember that we had a very similar slide for lists from a few minutes ago, and I will go through some of these methods in my demo. But before I do that, I also want to cover another type of collection, and that is tuples. Alright, so by now I hope you have understood the concept of a collection, which is to store multiple items in a single variable. We saw this with lists and dictionaries. And now tuples is also one of the built-in data types in Python that is used to store collections of data. And if you remember, lists use square brackets, dictionaries use braces or squiggly brackets, and now tuples use just a good old-fashioned parentheses. And in this example here, I created a tuple which holds integers from 1 to 6, and assigned it a name of tup1. But how do I know this is a tuple? Well, because it's a collection of items, and they are surrounded by parentheses. And similar to having a list function and a dictionary function to create these collections, we also have a tuple function as well. And the syntax is just the word tuple followed by empty parentheses. Now, tuple items are ordered, they allow duplicate values, and they are unchangeable. Now again, the fancy word for unchangeable is called immutable. So once the tuple is created, it cannot be changed, meaning that we cannot update, we cannot add or remove items after the tuple has been created. Now to access a tuple item, you refer to the index number inside the square brackets. So in this example, if I say tup index 0, I will get ABC. If I say tup index 1, then I will get 34, and so on. Now you might have noticed that tuples and lists are a bit similar, with the exception of one being mutable and the other being immutable. Plus, lists use brackets while tuples use parentheses. So when should we use tuples and why? Well, tuples should be used when you have a collection of data that doesn't need to change. This will make the code more efficient and provide the program with a performance boost. For new programmers, this might not mean much, but for the program, it's a more efficient way. Now, when it comes to methods associated with tuples, there are only 2 methods, count and index. And the reason is because tuples cannot be changed because they are immutable. So there is no need for a method to add, update, pop, and so on. Now, what does the count method do? Well, it doesn't count the total number of items in the tuple. Instead, we pass a tuple item to the count method as an argument, and it returns the count of how many times this particular tuple item appears in the tuple. And I'll show you an example of that as well. If you do want to get the total count of items in a tuple, we can call the len function in Python, which is one of the built-in functions in Python. As for the other tuple method called index, it also takes a tuple item as the argument, and it returns the index position of that particular item in the tuple. Again, don't worry, I'll show you examples in a few minutes. Alright, now there's a concept in Python that is called packing and unpacking. For example, when I create a tuple, I pack multiple items into this one variable, right? The example in front of us here, I have a tuple called person, and I packed it with the values Sam, 42, and male. So I packed 3 variables into one, which is nothing new as this is the concept of a collection. Now, what I can do is also unpack these 3 variables into 3 distinct individual variables and set them equal to the name of the packed tuple as you see here. Again, I'll show you an example in a few minutes. Okay, here's another light humor, and this time it's about the topic of functions. Now the cartoon shows a person asking, how do functions break up? And the other person answers, well, they stop calling each other. And in a moment, I hope you will start to understand this light humor. Alright, so we have been writing code for some time now, which is fine and all, but we need to learn how to write code that is organized. In other words, we can break up our loose code into smaller chunks of manageable and maintainable code, and those chunks of code are what we call functions. And one great advantage of using functions is that we can write it once, then we can use it many times down the road. So we define our function by storing all the code into that one chunk, then we can reuse that function by calling it from anywhere in our application. Actually, the term calling a function can be substituted by running a function, or invoking a function, or executing a function. So basically, all mean the same thing. And another way to look at a function is that it is a container that holds a few lines of code that perform a specific task. So that's a key point to note, is that functions should only do one thing. For example, we already worked and used built-in functions in Python, like the print function, the int function, and the input function. These functions do just one thing each, and that's it. The print function just prints whatever we pass in the parentheses. The input function just takes the user input and stores it into a string variable, and so on. Therefore, if we know that we use a certain type of task repeatedly, then it's a great candidate to contain that code into a function, so you can call it each time you want to run the same type of code. I mean, imagine when you look under the hood of the print function, you note that it's, say, 10 lines of code. So every time you want to print anything, you must copy and paste those same 10 lines of code. Too much, right? And what about if you realize you need to modify something in those 10 lines of code? That means you must make this change everywhere you see these 10 lines of code. However, if you have those 10 lines of code stored in a function, then you only need to make the change inside the function code block, and everywhere the function is called, we'll have that updated code as part of the function call already. So this is what a function looks like in Python. We start with a reserved keyword called def, which is short for define or definition, because we are defining a function, followed by a function name, followed by a pair of parentheses, followed by a colon. Then we have the body of the function, which is our code block. And just like the if statements we learned about before, these lines of code are indented to signify that they are part of this function. So this is the bare minimum of what the function can look like. And for the function name, please follow the same naming convention that you use for variable names, which by default is all lowercase, and if the name includes multiple words, then separate them with an underscore. Also, the name of your function needs to be descriptive, and since we said that functions should only do one simple task, then the naming part shouldn't be too difficult. And since we are talking about conventions, it's also best coding practices to leave 2 blank lines after the end of the function. So before you write another line of code that comes after your function, please separate the function's last line and the next line of code by 2 empty lines. It's also more comfortable on the eyes. So an example of a simple function can be this greet user function that we see in front of us here. We still have to start with the def keyword, which signals to the Python interpreter that we are defining a function, and that this function is called greet_user. Now, this is a very simple function that just has one line of code, and it just prints the message, hello user. Alright, so here's the basic structure of a function. We basically start with the def keyword, followed by some sort of a function name, and then in the parentheses, we can include parameters. Now, parameters are always optional, but if you do include parameters, that means you want to use them within the body of your function. Then after the colon, we have the indented code. So anything that's indented is part of the function body. All right, anything outside the indentation, like these two lines here, these mean they are outside the function and not part of the function. So this is just part of the regular Python code. Now, functions don't run by themselves. Someone has to call them. So down here, we have a function call. A function call basically is a line of code that calls the function by its name. So we call it by its name. In this case, it's add, because that's what the function is called. And then we follow by parentheses. And if the function is expecting parameters, since we see here num1, num2, then we need to pass them along. Now, when you pass parameters as part of a function call, we call these arguments. Now, sometimes I see this with experienced programmers. They use the words arguments and parameters interchangeably. It's no big deal, but again, just the proper way is when you pass values in the definition of the function, they are called parameters. But when you pass values as part of a function call, they're called arguments. All right? Okay, so we call the function name, we pass the arguments, and then this returns something from the function. So when you call this function call, the Python code goes up here and starts to process all the information in the indented code, and then it returns something. Now, some functions don't return anything, or they don't have a return statement. So we call these type of functions fruitless, because they don't bear any fruit. But if they do have a return statement and they do return something, then we call them fruitful. Now, even if you don't explicitly include a return statement, in the background, Python does return something, but it returns the word none, meaning nothing was returned. Okay, so the function can do two things. It can process a few things, and that's it, but it can process something and return something to the function call. All right, so this function call basically is going to pass 2 and 4. 2 is going to be num1, 4 is going to be num2, and then num1 is going to be used in this code statement, and num2 is going to be used in this code statement, and then used here and used here as well. Okay, and when this statement is executed, then addition is going to have some sort of a value, and that's what gets returned to the function call. And then whatever gets returned is going to be a value. We're going to assign it a variable name called res, and then we're going to print it out. Okay, so this again is the basic anatomy of what a structure of a function is. So here's one example of if-else code. We basically start with a hours variable and a rate variable, and basically we're going to be prompting the user to enter their hours, followed by entering their rate. So basically we're going to be calculating how much a person makes, giving how many hours they work based on a specific pay rate. The if statement starts with the if keyword, again that's a reserved word, followed by some sort of a condition. So here we say if the hours are larger than 40, okay, and hours is whatever the user enters in this first prompt. So if they enter more than 40, then this condition returns true, so we enter the indented code. However, if this condition is not true, meaning that they enter anything less than 40, then the else statement kicks in, and the indented code for the else statement is what gets executed. Once that's done, then we go on to the next line of code, which is this. Okay, and this basically returns a string, says pay, colon, and then followed by the value of whatever pay is, which is calculated based on this or this. All right, so I'm going to run this. And here, let's push this to the right. All right, so I'm being prompted to enter hours. Let's say I work 41 hours, hit enter. And let's say I make 20 hours, $20 an hour, hit enter. I get $830. Okay, so that works because 41 is more than 40. So basically, if hours is larger than 40, well, 41 is larger than 40. So we enter this indented code. And since with the if-else statements, only the first condition that's true is run, then we don't run the else statement at all. And once we're done with the if statement, then we go into the next line of code, which is print the pay and display the pay. All right, just like we see here exactly. These are the prompts, and then this is the return. Now, if I want to try a value under than 40, just so I can test my else statement, then I'm going to go back here, F5 to run my code. I'm going to say I worked only 30 hours, and let's say I make $10 an hour, and then hit enter, and I get 300, which is correct. So it checks for if hours is greater than 40. Well, it's not, so this condition is false. Then it skips this line and then goes to the else block, and the else is a catch-all, so it runs this line, this indented code, and then it prints it out. All right. Now notice that in both examples I've been entering integers. Okay. Now what happened if someone says, well, I worked 10.5 hours, or what happened if I make $10.30 an hour? So let's run that and see what happens. So let's say I worked 10.5 hours, and this happens. Okay, I get a traceback error, and the error is inval literal for int with base 10, 10.5. So this, and it tells me, here, let me show you this. It tells me also the line 4. Okay. Now, if you don't see line numbers, then I can go up to the options menu and then say show line numbers. Okay. So line 4 is this, and basically it's complaining that for my entered hours, I entered a float, which is a decimal number, 10.5. And here I'm trying to convert this into an int. All right, so that creates this value error. Okay, so this is not nice to have. It's not nice to have the code blow up in the user's face. We need somehow to be able to handle this gracefully. Okay, so I'll show you how we can handle that gracefully. All right, so this is exactly the same code that we had before. However, I took my troubling code, or the code that might give me some errors, and I wrapped it around a try and except code block. All right, so Python is going to say, okay, let's try this code here, and if any of this throws an error, then I'm going to jump to the except block and run this code. All right, so same exact code, nothing has changed. Okay, I'm still prompting the hours, the rate. I'm converting it over to an int because we're dealing with number and mathematical calculations, and then we're printing it out. All right, so let's run this code and see what happens now. So enter hours. I'm going to say 10.5 this time again. Now, instead of getting this error, I got a gracefully handled code that basically says, error, please enter numeric input. All right. So that's one way to gracefully handle an error using the try and except block. All right. Now you could also do the else and finally. All right, so I'm going to come down here and I'll do an else, and then I'll just do a simple print statement and say we are in the else portion of the code, and then we'll do a finally, and we'll print we are in the finally part of the code. All right, so let's run this and see what happens. I'm going to enter 10 hours, I'm going to enter $10, and I get the pay. All right, and because there was no error in the try portion, then the else part ran, and then finally will also run regardless if we get an error or not. Okay, so that's how the else and finally works. Now this is when the try doesn't generate an error, but let's generate an error. So let's run this again, F5. I'm going to do 10.5, which I know throws an error. Okay, so now the try generated an error, so we go into the except block, which prints an error, and then we go to the finally block, which runs this code. All right, so that's how the try, except, else, finally works in unison. Now in the previous examples, we've been seeing some simple if-else statements with one condition. But we learned that there's something called compound conditions, where we have not just one condition to check for, but we can have multiple conditions to check for. And here we talk about the AND logical operator as well as the OR logical operator. Okay, so this code basically says I'm going to be defining three variables. X is 50, Y is 15, Z is 25. Then we have an if statement, and the if statement says if X is equal to 50, now remember the double equal sign is an equality operator, all right? The double equal sign. The single equal sign is an assignment operator, so don't confuse both of them, all right? So if X is equal to 50, and that's a logical operator, Y is equal to 195, and Z is equal to 25. With the AND operator, all three conditions have to be true for this entire definition to be true, all right? So it's an all or nothing. So is X equal to 50? Yes, it is. Is Y equal to 195? No, it's not. Is Z equals to 25? Yes, it is. So as long as one of them fails, which in this case this fails, then all of this condition will not return a true, will be a false. So we go to the else and then print this line. Okay, just because one of them is not true. So let's run this and test it. F5. At least one comparison is not true. So that means we came here, which is correct, because 195 is not true. So let's change this to 15. So now X is 50. Yes, it is. Is Y 15? Yes, it is. And is Z 25? Yes, it is. So the ANDs fulfill this compound condition, and they're all true. So if I run this code, I should get the all comparisons are true in the AND statements. All right, so that's what the AND does when you're doing if statements with compound conditions. Let's check out the OR part. All right, so let me comment this part out. Let's bring this back in. All right, so if X is equal to 50, or Y is equal to 115, or Z is equal to 20. So we know that Y is not equal to 115, it's equal to 15. And we know that Z is not equal to 20, it's equal to 25. But we do know that X is equal to 50, okay? So the OR basically says at least one just has to be true. I could have 100 conditions to check for, but if only one answers to true, then this whole line is true. Okay, that's what the difference between the OR and the AND. AND is all or nothing, OR is just one, and that's it. All right, so let's run this code. I should get this output because 50 is true while the rest is false. But since only one is true, then I'm going to enter the indented code here. So let's run this code, and I get at least one comparison is true in the OR statements, and that's correct. All right. Now if you change this and make this one wrong as well, so this is false, this is false, and this is false. Okay, so none of them are true, and if we do that, then nothing is true. Okay, so again, that's the difference between the AND logical operator and the OR logical operator. Okay, let's take a look at a functions example. So this is the same code that we saw regarding the pay, but what I did was I took the exact code and I dumped it into a function. Okay, so we learned that to create a function, we have to start with a def keyword, followed by the name of a function, and again, try to make it as descriptive as possible, and then followed by any parameters that you need for the function to use in its code. All right, and then we have a colon, and then after the colon, just like the if statement, we have indented code. All right, now inside the function, this is the code that I want to run when the function gets called. So how do we call this function? Well, down here I have a print statement that says pay colon, that's just a string, and then here is my function call. All right, so the function call gets executes by calling the function by its name, so compute underscore pay, which is this function name, and then I pass it the correct number of arguments. So if the function is expecting 2 arguments, then I need to pass it 2 arguments. If I don't, I'm going to get an error, and I'll show you an example in just a moment. All right, and then up here we have what we've seen before, which is, get prompt for enter hours and get prompted for enter rate. Once you enter these 2 pieces of information, they get stored in 2 variables, h and r, and then we run to this code and we execute this code, and this includes a function call that passes h and r. So once this gets called, the interpreter goes all the way up to here, starts to execute this function, and then goes down line by line, and here's a return statement. So once the pay gets computed, then it returns pay to the function call over here. All right, so let's run that and see how that works. Here's F5, enter hours. Let's say I worked 40 hours and I get paid 20 hours, so it's 800. Okay, now that's our happy path. Now sometimes we make a mistake, so instead of passing 2 arguments when we expect 2 parameters, I'm just going to pass 1, and let's see what happens. 10, and let's do 10. Alright, so I get a traceback error, which is expected, and the type error is that compute pay is missing 1 required positional argument rate. Alright, so we're expecting 2 arguments, but we only passed 1. And here's another example of a function as well, just to get us more practice. I basically start with a def keyword, followed by a name of a function, followed by parameter, and then a colon, and then the code. Alright, so this function basically is called is_even. It takes 1 argument, and then in the code itself it says if n module 2 is equal to 0. So the module operator basically returns the remainder of a division problem. So I take n module 2, meaning that is this number when divided by 2, is it going to return 0 remainder. Okay, so if it's 0, if you divide anything by 2 and you get a 0 for the remainder, that means that this number is an even number. Okay, and if that's the case, if this is true, then I'm going to return true in my function call. But if it's not, meaning it's else, then I'm going to return false. Alright, so I'm going to prompt the user to enter any number. I'm going to convert it to an int, then I'm going to print the function call and pass it number, which is what I captured from the user input. Alright, so let's run that. Enter number, let's do 688, hit enter, and I get it true because 688 is a even number. Let's run it again. You always have to test your code in all different types, so let's do 31, which is an odd number, hit enter, and now I get a false, which is expected. Okay, now the way Python operates, again, it's an interpreted language, so code is interpreted line by line. So when we start at the very top, when Python starts looking at this code, it sees a comment, so it ignores it because there's nothing to execute. Then it comes down here and it sees a function, okay, based on the def keyword, which is a reserved word. So it says, okay, this is a function. Is it going to run this code? No, it's not, because this is just a function. Functions do not run by themselves. Someone has to call them, okay? And then we come down to the next line of code, which is an input, and then we prompt the user, whatever they enter, we convert it to an int, and then from there we assign the value to a variable called number. And then we go into the next line. It's a print statement, so I'm going to print this. Now what is this? Well, this is the function name, so it's a function call, and I'm going to pass it an argument. So once this function name is called, then the interpreter goes all the way back to here and then starts processing this code. Okay, that's basically the sequence of events. Okay, let's start working now with lists. Now, lists is one of the collections of data types in Python. Again, we have lists, we have dictionaries, and we have tuples and sets. So this is going to be a lot of examples for lists. Alright, so here I have a list defined, and I've called it fruits, and I'm assigning it these values. Okay, now how do I know this is a list? Well, first of all, it's a collection of items, and they're surrounded by square brackets. Okay, so my list includes string value apple, blueberry, kiwi, banana, kiwi again, and watermelon. Now we are allowed to have duplicates in lists, so this is acceptable. Alright, so I'm going to start uncommenting some code just to see what we get back. So here's just a simple print statement. I just want to see what happens when I print fruits, and fruits is a list. So let's print that out and see what happens. I get exactly what the list is, which is just a list of items. Okay, nothing too special here. Alright, I'm gonna undo this. Now let's uncomment that. Now to get a specific item in your list, you have to use the index notation. So fruits index 2 is going to get the item that's in the list that's in the third location, third index location. Why third index location when I say 2? Well, because index are 0 based. So this is index 0. This is index 1, and this is index 2. So technically, it's the first, second, third item. So you have to start getting used to the index notation idea and that it starts at 0. So if I run this, I get Kiwi. And Kiwi is my 0 index, 1 index, 2 index. So this is correct. All right. Now sometimes you don't want just one item. Sometimes you want multiple items. Okay. So now we can use index notations, but using a range for the index notation. So I'm going to print out from my fruits list starting at index location 2. So start from 2 and then stop at 4. And if you remember also from our last week's discussion, the stop does not include the stop. Just like when you're driving up to a stop sign with a car, you don't stop at the stop sign, or you don't stop after the stop sign, you stop before the stop sign, or at least that's what the law says. So 4, which is at the stop, is not included. So if I want to get fruits index 2 to 4, then it's going to be, well, this is 0, 1, 2, so this is index 2, then I need to get index 3, but I do not include index 4. So I should only get back kiwi and banana. So if I run this, I get kiwi and banana, which is correct. So basically I'm getting a subset of the items in my list. This is the entire list, and then this is a single item from my list, but this is a range of items in my list. Okay. Now the notation also for the index, if I don't include anything in the start value, that means start at the very beginning. All right. So if my starting point is empty, that means start at index 0, and then the 4 is the stop, so I'm going to stop at 3, or technically include 3 but not include 4. So if I start at 0, I'm going to get this, and that's 1, and that's 2, and that's 3, and that's 4, but I don't include 4, so I'm only going to get these values. So let's test F5, and I get the first 4 values: apple, blueberry, kiwi, and banana, which is correct. All right. Now what happens if I switch? I specify a starting point, but I don't specify an ending point. So if you would guess, then you start at 3, or index location 3, and then since the end is not included, then, or I'm sorry, it's not specified, and then it's going to go all the way to the end. So if I start at index 0, I'm sorry, index 3 would be 0, 1, 2, 3. So I start at banana, and I go all the way to the end. So am I going to get banana, kiwi, watermelon? Well, let's find out. Uncomment this guy. Let's run it. And that's what I get. We start at index 3, which is banana, and then go all the way to the end, whatever the end is. Okay. Now sometimes you want to get the very last item, or you want to go kind of backwards. So to do that, we use a negative notation. So -1 basically means it's going to get the very last item. -2 would be the second last item, -3, and so on. All right. So -1 should return back watermelon, because that means it's the last item. So if I run this, I get watermelon. Okay. All right, let's comment that out again. Okay, now if you want to update items in the list, because you are allowed to update items in a list, because lists are mutable, then this is the notation to do it. Let's comment this one out. So the way to do it is you call the list's name followed by the location of the item that you want to update, and then set it to whatever value you want to give it. So right now index 1, this is index 0, this is index 1. Right now this is blueberry. But if I say fruits 1 is set equal to orange, then blueberry is going to be updated with orange. Okay, and then I want to print it out just to see what happens. Okay, because right now it's apple, blueberry, kiwi, banana, kiwi, watermelon for the fruits list. After this change, I'm going to print my fruits list and see what I get back. And there we go. Now I get back the list, but it's no longer blueberry, it's now orange. So that's how you can update a value in a list. Okay. You could also loop through a list, very nice and quick. And all you have to do is do a for loop, followed by an iteration variable, followed by the in reserved word, followed by whatever sequence of items you want to loop through. So we are looping through our list called fruits, and once we do that, we print x. Now we have not covered for loops yet, so I'm just going to run it for you, and we'll explain for loops in the next week. And there we go. We loop through item by item, and we just print it out. Okay. Now, it's very typical also to say, well, how many items do I have in my list? I need to find that out. So we do that using the len method. So len is basically well, short for length, but it's a built-in function in Python that allows you to return the length of an item. It could be the length of a word, so it tells you how many characters are in it, or it could be, if it's a length of a list, it's going to tell you how many items in the collection. All right, so we have 1, 2, 3, 4, 5, 6. So if I run this, I get 6. Okay, so that's what the len function can do when you pass it a list as an argument. Now, lists comes with a slew of methods. And the very first one I wanted to show you is the append method. So let me just comment that out. All right, so the way to do it is you call the name of the list, which is fruits, followed by a dot notation, followed by the append method. Okay, now it's a method and not a function, because the difference between a method and a function is if the method or if the function belongs to a class. In this case, fruits is a class of a list. If it belongs to a class, then we call it a method. But if the function is a standalone function and does not belong to a class, then we just call it a function. All right, so fruits.append is basically going to take an argument and it's going to append it to your existing list. So I'm going to append raspberry to my fruits list. Okay, and if you remember, fruits does not include raspberry yet. All right, so let's run this code. And let's bring this a little bit back so we can see the whole thing. And there we go. So I originally had apple, blueberry, kiwi, banana, kiwi, watermelon, and now I just added raspberry. Okay. Now, why is blueberry back and not orange? Well, because I reran my code and I defined fruits to have blueberry in it, just in case you were wondering. So that's what the append does. The append adds something to the fruits list, and that's allowed because lists are immutable. Let's comment that out. Fruits also has a copy method. All right, let's take a look at that. All right, it doesn't take any arguments, so we're going to call the copy method on fruits, and whatever that comes back as, we're going to assign it or store that value into a new variable called copy. All right, and then I'm going to basically print out the new copy list is copy, and I want also to show you that it's basically a copy of fruits, so I'm going to print out also fruits just to make sure that they're a copy of each other. So let's run that. All right, let's bring this back in again, like that. So the new copy list is apple, blueberry, kiwi, banana, kiwi, watermelon, and the original fruits list is apple, blueberry, kiwi, banana, kiwi, watermelon. So they're identical. All right, and that's what the copy method does. Again, there are a lot of methods you can apply to lists. We learned append, now we learned copy. Let's look at some more. All right, there is a method called count, and again, it's part of the list class, and you need to pass it an argument. So the argument is kiwi. Now we have kiwi up here, you have kiwi here, and I have kiwi here. Now is it going to return how many times it appears? Well, let's find out. Run it, and I get 2. Okay, so kiwi has 2 counts in the fruits list. So anytime you want to know how many times an item appears, if you're looking for maybe duplicates, then you can do that. Okay, let's comment that out, and let's bring this back in. All right, now there is an extend method. So an extend method, as the name kind of implies, we're going to extend the fruits list with items in another list. All right, so here I have a list called tropical underscore fruits. Why is it a list? Well, it's a combination of items or a collection of items, and they are surrounded by square brackets. So this is another list. Okay, up here I have fruits list, and then down here I have tropical fruits list. Now what I'm going to do is, and it has some values, and what I'm going to do is I'm going to take the fruits list, I'm going to extend it by adding whatever is inside the tropical fruits list. Then I'm going to print out fruits to see how it changed. So technically, fruits now should look exactly like this, but have 2 more items extended, which is the mango and pomegranate. So let's confirm if that's correct. And there we go. After watermelon, we have mango, and we have pomegranate. All right, so that's what the extend method just did. All right, next method is insert. So you might be confused, well, why do I need insert if I already have append? Well, you might have noticed that when I ran the append method, the addition was thrown at the very end, okay? Which sometimes could be fine, but what happens if you want to append it into a specific location and not just at the end? So that's where the insert method comes in. The insert method basically requires two arguments, a location argument and a value argument. So this insert method is going to apply to the fruits list. It's going to insert the value tangerine in the index 2 location. All right, then I'm going to print out the fruits list just to see what I'm getting back, how the fruits list has changed. So fruits right now has apple, blueberry, kiwi, banana, kiwi, watermelon, and this is the 0 index, this is the 1 index, this is the 2 index. So kiwi is in the 2 index. I am going to insert tangerine in the 2 index. Now I'm not going to replace the 2 index, I'm going to insert it in the 2 index, and then all this would be shifted one step to the right. Okay, so let's verify that that's the case. Let's run this. So now I have apple, blueberry, and then instead of kiwi, I now inserted tangerine, and then kiwi, banana, kiwi, watermelon just got bumped to the right. So that's the difference between the append and insert. All right. Another method is pop. All right, so let's assume you don't know what pop is, but let's run it and see what happens to our fruits list. So I used to have apple, blueberry, banana, kiwi, watermelon, but something seems short. So something went missing. All right, my original fruits was apple, blueberry, kiwi, banana, kiwi, watermelon. All right, so it looks like kiwi, which is index 2, got kicked out. Apple, blueberry, there is no kiwi, banana, kiwi, watermelon. So the pop method popped out this whatever was in the index 2 location. Okay, so that's what pop does. So pop takes a index location as a argument. Now you might not know what is in index location 2, but whatever is in index location 2 just got popped out, meaning it got deleted. All right. Now what happens if you want to delete an item by its name and not by its location? Well, instead of using pop, we're going to use the remove method. Again, I told you there's a lot of methods for lists. So the remove method, I'm going to call it on the name of my list. I'm going to pass it the name of the item that I want to remove. Now, I don't recall happy being one of the items. So let's see what happens. I get a value error. Why? Because X, which I just passed here, happy, is not on the list. Okay, so be careful when you're trying to remove an item that does not exist, you're going to get an error. So let's change this to, well, let's change it to banana. Okay, and banana is here. So I'm going to run this code, then I'm going to print out the fruits list to see if it did remove it or not. F5, there we go, there is no banana anymore. So that's what the remove does. Alright, so let's move on to the next method, and that is sort. So from the name you can guess that this is going to sort our list. So our list right now is apple, blueberry, kiwi, banana, kiwi, watermelon. So this is a list of strings, and if we're going to sort something that's a string, then it's going to sort it alphabetically. So the A is going to come first, then the B, then the K, and then the W. All right, so let's run this code, and there we go. So now our list has been sorted by alphabetical order, so the A's first, then the B's, then the K's, then the W. All right, now there's another method called reverse. So do you think reverse is going to reverse the order? Well, let's try that out, see what happens. I'm going to run this code. And that's exactly what it did. It reversed it, but did not put it in alphabetical order, because the order is apple, blueberry, kiwi. Actually, no, that's that. Well, it used to be apple, blueberry, kiwi, banana, kiwi, watermelon, but when I call the reverse method on fruits, it basically reversed the order. So whatever was last became first, whatever was first became last. So that's what the reverse does. And there will be times where you want to erase everything or delete everything that's in your list. Basically, you want to clear your list. So clear is a method that you can call on a list, and then when you print it, you're going to get an empty list. So let's try that out. And there we go. Bracket, bracket, meaning there's nothing in the middle, so no more values. So this is an empty list because we just called the clear method on it. Okay. Now sometimes you can have a list within a list. So what does that mean? Well, take a look at this code here. All right, so I have fruits just like before, and it starts out with orange, berries, but then in this item here, I have another list, and then I have an item, and then an item, and then close my list. So one item could be a collection of items. All right, so the question now becomes is, well, how do I call an item inside an item? Because this is the big list, and then this is a list inside the big list. So the way to do it is same exact way as we've been doing it up here, but not just one index location. We're going to need two index locations. Okay, so this is called a 2D list because it's two-dimensional. We have the big dimension, and then inside the big dimension we have another dimension. So now we have 2D list. So the way to call it is, now we know this is index location 0, this is index location 1, and all of this is index location 2. So I know that my first dimension is index location 2. So I start calling it like this, fruits index 2. And then say I want raspberry, okay? And this needs to be commented out. Say I want to find raspberry. So raspberry is, once I'm in this location, then now the counter starts again. This is going to be 0, this is going to be 1, that's going to be 2. Okay? So 0, 1. So then this would be index 1. So now I have two index locations, one for the big list and then one for the sub list. Alright, so this should return back raspberry. So if I run this, I get raspberry. Alright, so these were some of the methods. Again, lists come with a lot of methods. I think I covered most of them, but I'm sure there's a few that I missed. So please do follow up with the Python documentation on lists. And again, if you have any questions, please do let me know. Okay, so I have a notebook open here, a Jupyter notebook with a lot of examples for dictionaries. And basically a dictionary is a collection data type. Just like we have lists and tuples and sets, we also have dictionaries. Now, from what we learned already, dictionaries are basically a collection of key value pairs. So here I first created a dictionary, I called it cars. And then I know it's a dictionary because first of all, it's surrounded by braces or squiggly brackets. And then inside the braces, I basically have a combination of a key and a value for that key. And they're separated by a colon. And then the different key value pairs are separated from each other by a comma. Okay, so this is the name of the dictionary. This is my first key value pair. This is the key, followed by a colon. This is the value. And then if I need more key value pairs, then I do a comma. Then I go to my next key value pair. If I need another one, I do a comma, then go to my next key value pair. And if that's the last one, then I stop and I don't do a comma anymore. Okay, but that's what a key value pair as part of a dictionary, which is a collection data type. Now, how do we use dictionaries? How do we call them? What are the methods that apply on them? Well, to display the full dictionary, I'm just going to print it out. Okay, and if you want to, let's comment this out first. So if I run this, I get just my entire dictionary. And it's a dictionary again because it's surrounded by braces and it has key value pairs separated by commas. Alright, now if you don't want the entire dictionary and you want a specific one or a specific value of a key, then I can comment this out, uncomment this back in. So the syntax is you call the item by first calling the dictionary name, which is cars, followed by the name of the key. So brand is a key, model is a key, year is a key. Ford is the value of the key called brand. Mustang is the value for the key called model. And 1964, is the value for the key called year. Now, keys are always going to be string types, so they're always going to be surrounded by double quotes. And value, because it's a value of something, then sometimes it could be a string, sometimes it could be an integer, and so on. So values can be different data types, but the keys are always going to be string types. All right. So if I want the value of the key model, which is Mustang, then I call it by the dictionary's name, and then in the hard brackets or in the index type notation, I don't give it a location, but I give it the actual name of the key. So cars index model, then it's going to give me the value of whatever the key model holds, which is Mustang. All right, so if I run this, then I get Mustang. Okay, now there are multiple ways you can actually get the value of a key. So down here is another example. I have the same exact dictionary, and here I have a variable called model name. I'm going to set it equal to cars, and then there's a method on dictionaries called get. So when you call the get method, you need to pass it the name of the key. So key model is this key here. So I'm going to say cars.get and then pass it the name of the key, and that's going to get the value of this key. Then this value is going to get returned. It's going to be assigned to a new variable called model name, and I'm going to print out the model name. So if I run this, I get Mustang, because Mustang is the value of the key model. Now, dictionaries also do not allow duplicate keys. All right, so here you can see the cars dictionary again, and then I have brand, model, and then I have year, which is 1964, and then I have year again, which is 2023. So what happens when you have multiple keys with two different values? Well, Python is going to basically return the very last value of the very last duplicated key. Okay, so cars year is basically cars is the name of the dictionary, year is the name of the key, so this is going to return the value of the year key. But instead of 1964, which is the first one, it's going to return the very last one that it has access to, which is the 2023 value. So if I run this, I get 2023 instead of 1964. So while duplicates seem to be allowed in dictionaries, only the last one is going to be returned. Let's look at the next example. Another method in dictionaries is keys. All right, so if you think keys is probably going to return the keys of my cars dictionary. All right, so let's see if that's the case. That's exactly the case. So the keys method is a method you can apply to dictionaries that basically return just the key names. Okay, brand is the key, model is another key, year is another key. All right, what happens if I want to get just the values? Well, there's another method for it called values. Let's bring this up a bit. So values is a method that you can apply to dictionaries that's going to return just the values. So let's run that and see. That's exactly what I get. I get just the values. All right. Now what happens if you want to get both? If you want to get both the key and the value? Well, there's another method called items. So if I do cars.items and I run it, I get basically this. I get the first item, which is key and value pair, another key value pair, another key value pair, another key value pair. All right. Now what happens if you also want to check if a value or if a key is part of your dictionary? Well, we can use the if statement followed by the name of the key and then the in reserved word followed by the name of the dictionary. So I'm going to say if model, which is a key, in cars. If this statement is true, if the key model is in my cars dictionary, then this is true, then enter into my indented code. All right. If not, then I don't have an else statement, so nothing's going to happen. So let's run this. And I get yes, model is one of the keys in the cars dictionary. Well, what happens if I change it to a capital M? Because we know that Python is case sensitive. I run this now. I get no output because there is no else statement. Okay, because model, the key model, is not part of cars. Because again, capital M is different than lowercase m. All right. Okay, now how do we update values in our dictionary? Well, this example here has our same cars dictionary, brand Ford, model Mustang, year 1964. Then I'm going to print cars just to see what it is, and it is exactly what it is. It hasn't changed yet. Alright, let me do some changes. I'm going to comment this guy out. Alright, so I have cars, which is the name of a dictionary, and then in index notations I'm going to call the key color, I'm going to set it equal to red. But wait a minute, there is no key called color. So how can I update it? Well, with dictionaries, if you're trying to update a value for a key that does not exist, it will insert it for you and assign this value to it. Okay, so right now I don't have color. So if I do cars color equal to red, then it's going to add a new key value pair called color with a value of red. So let's test that out. Okay, so I printed the cars dictionary before the change, and then I printed it after the change. So before the change, there was no color. Then after the change, here's the color. Red item has been added. Okay, so this was the behavior because there was no key called color. All right, but what happened if there is a key called color or an existing key? How do I update it? Well, there are a couple of ways. Actually, more than a couple of ways. So one way, actually, let me get rid of this first. All right, so we can call the update method. So dictionaries have a method called update, and you pass it the actual value that you want to update. So I'm going to update body with a value of sedan. Now I still don't have a key called body, let alone a value that's called sedan. So just like we did here when there was no key with a value red, it created one for us. With the update method, I'm also going to pass it a key that does not exist and a value. So when I run that, now I have a updated dictionary with a key value pair of body sedan. So this did the trick. This also did the trick. But again, what happened if I want to update a value that exists? Then let's get rid of this. Let's bring this in. So here I'm saying cars model is equal to country. So I do have a key called model already, but the value is Mustang. All right. What I'm doing here is I'm saying, okay, take the model key, which is part of cars dictionary, and assign it a value of country. Whatever its current value is, override it. Okay, so I'm going to run this. And now initially model was Mustang, but now model has a value of country. Okay, so technically I can do the same thing also with the update method. Let me get rid of this. Let's bring this in. So just like I did an update method, but when I passed it a value of a key that does not exist, it created it for me. The same thing also with update. If I pass a key that does exist, it's going to update it for me. So model is Mustang. I'm going to change it to Galaxy. So let's test this. There we go. Model has been updated from Mustang to Galaxy. All right. Another method that we can call on dictionaries is pop item. Okay, now you might remember from list that pop usually is associated with getting rid of something. So pop item, is it going to get rid of the last key value pair? Well, let's give it a shot. I'm going to print out the original cars dictionary. I'm going to pop an item. Then I'm going to call the cars dictionary one more time to see how it changed. So let's run this. Okay, so pop item with no parameters or arguments passed basically deleted the last item or popped out the last item in my dictionary. Now what happens if you want to pop out a specific item in your dictionary, just like we did with lists before? Then we can call the pop method. So the pop method takes an argument of the name of the key. So if you want to pop out model, okay, specifically model, then you need to call the pop method, pass it the name of the key, and then I'm going to print the cars dictionary before, I'm going to print the cars dictionary after to see if key model has been gone. And yes, we used to have model Mustang, and now we don't. So pop item is going to get rid of the very last item, and pop, when you pass the name of the key, is going to get rid of the specific key. All right, and just like with lists, we had a clear method. Dictionary also has a clear method. So I'm going to print cars before I do anything to it. So it's going to return the value of these key value pairs. Then I'm going to call the clear method on my cars dictionary and then print it out again, and it should be an empty dictionary. So let's test it out. Initial dictionary is filled with items, and then I cleared it, so now it's empty. And here we can also loop through a dictionary list of items, just like we did with lists. But again, we haven't covered loops yet. So for is the reserved key, x is an iteration variable, in is another reserved keyword, and then cars is the name of the dictionary, which is a list of item or a sequence of items. So for x, for every x in cars, do this. Okay, let's run that, and I get basically a list of keys. All right, now I got keys even though I didn't specify keys. So here's something to watch out for. If you want to loop through cars just by the name of the dictionary without specifying keys or items or values, then just saying for x in cars is going to return just keys. But you can also call it, let me get rid of this, you can also call it by calling the keys method. So we learned about the keys method a few moments ago. So the keys method is going to return just the keys. Okay, so I'm going to loop through the key in the keys elements in my cars dictionary. So that's basically the same thing as what I did up here. So if I uncomment this out and I run this, actually let's comment this out as well and call it, I get basically the same exact thing. So when you loop through cars just by the name of the dictionary, you get keys. And when you loop through cars.keys, you also get keys. Okay, if you want to get values, you basically loop through cars.values. That's going to return values, not keys. There we go. And if you want to loop through both the key and the value, then you call the items method, and that's going to give you both key and value. So by default, when you loop through just the name of the dictionary, you're technically as if calling the keys method. If you want values, then you call the values method. And if you want to loop through just the items, then you call the items method. Now again, just like lists, there are a lot of methods for dictionaries, and I don't think I covered all of them, but please do refer to the Python documentation for more information. Okay, here's another Jupyter notebook that has a lot of examples for you working with tuples. At the very first cell, I basically defined a tuple called tup1, and it includes values A, B, C, D, and E. Now, how do I know this is a tuple? Well, first of all, it's a collection of items, and it's also surrounded by parentheses. Now, to access a tuple, we basically, very similar to lists, we call the tuple name and then follow it with some index notation. So I have a tup1 with these values in it, and then I'm going to print out some tuple index locations. So tup1, which is the name of my tuple, and then index 0 basically is going to fetch the very first item in my tuple. So the very first item is 5. So tup1 index 0, remember indexes are 0 based, so 0 would be the first item. So tup1 index 0 should return the value 5. And then tup1 index -1, just like we saw with lists, this would be basically the very last item in our tuple, which would be 193. And then we can also use range notations where we have a start and stop. So the start is inclusive while the stop is not inclusive. So tup1 index 1 to 5 would mean it starts at 1 and include index 1, but then it's going to stop at 5 and not include index 5. So index 1 is basically 22, index 2, index 3, and index 4. All right, it's not going to include index 5. So let's run this and test that out. There we go. So tup index 0 is 5, and then the very last item is 193, and from 1 to 5 is 22, 94, 4102, and 914, which is correct. All right. Now, a common thing to do also with tuples is to check if an item in a tuple exists. So here I have a tuple called fruits, and it contains the items apple, banana, and cherry. Then I'm going to create a variable called fruit. I'm going to set it equal to banana. Okay. Now notice I have banana with a capital B versus what I have in my tuple, which is banana with a lowercase b. And of course, Python is case sensitive. And then we have an if statement. I say if fruit, which is this value here, if fruit is in fruits. So if banana with a capital B is in fruits, which is this list here, which is this tuple, I'm sorry, here. All right, if so, if this condition is true, then go into the indented code and run the code. Else, if this does not answer to true, then go to the else block and print or run the statements in the else block. All right, now we could already guess that banana with a capital B, which is the value for fruit, is not the same as banana with a lowercase b. So if I run this, I should get the else treatment, meaning that the name of the fruit is not in the fruits tuple. So if I run this, that's what I get. Banana is not in the fruits tuple. But if I change the value of fruit to a lowercase b, and now it matches banana, and I run it, now I get banana is in the fruits tuple. Now from the PowerPoint presentation, you might recall that we had two methods for tuples, count and index, and the reason being is that tuples are immutable, so we can't change them. So the two methods are the count method and the index method. So here I have a tuple that contains items, integers 1, 3, 9, 7, 8, 7, 5, 4, 6, 8, 5. Okay, and then I'm going to call the count method on my tuple. So I call the tuple by its name, tup1, then a dot notation, and then the method that I want to call, which is count. Now count is not going to actually count the number of items in my tuple. To do that, you have to use the len function, okay, which is a built-in function in Python. So count, what does it do is it takes one argument, which is a item in your tuple, and it should return how many instances this item appears in the tuple. So 7 appears 2 times. Okay, so let's see what we get back when we run this. I get 2. Okay, so the count, and you pass it the item that you want to count for, is going to return how many items, how many instances this item appears in your tuple. So that's what the count method does. And the next method is the index method, and as you can see here, it also takes an argument. Now the argument basically is an item that's in your tuple. Okay, and this is not going to return the count. This is going to return the index location for your item. Okay, so I have, would be index 0, this would be index 1, this would be index 2, this would be index 3. So index 7, the method index with an argument of 7, will return the very first index location for that number. Now why say the first? Because 7, I have multiple 7s. Okay, so index 7, which is the method index, when I call it from a tuple item, that's going to return the index location. So if I run this, I should get 0, 1, 2, 3. I should get 3, which is the index location of the item that I'm passing as an argument. So if I run this, I get 3, which is correct. Index 0, index 1, index 2, index 3. All right. We also talked about packing and unpacking our tuples, or basically our collections. So here I have a variable called person, and it's basically a tuple. Why is it a tuple? Well, because again, it's a collection of items that are surrounded by parentheses. Okay, so technically I am packing a lot of information into one variable, and I'm calling it person. But then I could also go the other way around, and I could unpack my values. So basically I'm going to say, out of person, I'm going to unpack into 2 variables. I'm going to create a variable called name, I'm going to create a variable called age, and I'm going to set it equal to person. So when you create a collection, you're basically packing information in it, but then you have the option, if you want to, you have the option of unpacking that same information from your collection type. And then when you print them out one by one, you should get Sam for name, and you should get 42 for age. So if I run this, it's exactly what I get. I print name, so I get Sam, and I print age, which I get 42. So name is basically the output, or basically the unpacking of the first item in my tuple, and then age is my second item when I unpacked the person tuple. And we can do the same thing again with the same packing and unpacking with lists. So this is exactly the same code. The only difference is here I have brackets, as opposed to up here I have parentheses. So the difference is this is a tuple, and then this is a list. But they work exactly the same way. I basically pack a lot of information into one collection, and then I can have the option to unpack the items into new variables that I create. And then when I run this, I get exactly the same thing. So this is going to be due on Sunday, and you need to upload a file as your submission. Please read the context and also follow the steps. But basically it's saying that we need to click on this link to access the Jupyter Notebook. So we've worked with Trinket before, we've worked with VS Code, and this week we're going to be using Jupyter Notebooks. So again, there are a lot of different editors and ways to write code or write Python code, and Jupyter Notebooks is one of them. Now I already did show you some examples of a Jupyter Notebook when I was doing the dictionary demo. So when I click on this link, what this is going to do is it's going to open up a Jupyter Notebook, but it's going to open up in Google Colab. Now Google Colab, well, Colab basically is short for collaboration, and basically this is an online Jupyter Notebook environment. Okay, now I do have a video on how to use Jupyter Notebooks, so I'm going to share that in the class, or I could email to you as well. But this is basically a Jupyter Notebook in Google Colab. So Google Colab, again, is an online environment that basically gives you access to Python engine. It gives you access to hard disk space and gives you access to memory. Okay, so you could run your code without having to install anything. All you need is just an account on Google. All right. Now this opens up in a .pynb extension, which is IPy notebook. All right. Now there's a lot to read here, and all this is basically just review for stuff that you kind of already know by now. All right. But let me show you just a quick walkthrough of how to use Google Colab. Now first, you need to connect to the online environment. Okay, so when you connect to it, what this is going to do is it's going to give you a hard disk space, and it's going to give you memory to use. So it's technically as if you're connecting to a cloud resource and using the cloud resource. So now I'm connected, and now if you hover over it, you can see that I have some RAM and I have some disk space to play with. And then in general, the Google Colab has two types of cells. It has a code cell and a text cell. Text cell is just where you can type text, and then the code cell are these cells that are in gray, where you can basically click the play button. Okay, that's the first time, so I'm going to say run anyway, and then you get the output right away. Okay, so again, the gray cells are for coding. You can write your Python code, and then when you click on play, it's going to display it down here. So here it talks about basically just, some basic functions, talks about variables. Again, read everything, please. Talks about the input function, talks about conditionals. So these are all practice of basic Python stuff that you should, review yourself. And then down here, we're going to start to be putting it all together. Okay, so the putting it all together, basically building a chatbot. So that's the goal for this lab. We're going to be building a chatbot. And the chatbot basically says, ask the customer for their name, refer to the customer by name in the following messages, and then ask the customer their US shoe size and if they wear men's or women's shoes. Then tell the customer for their European shoe size. For men's shoe, the way to calculate it is we add 33 to whatever their US shoe size is, and if it's for women, then we add 31 to their US shoe size. Okay, and then here it says we've given you sample code for the chatbot below, but it's not complete yet. Fill in the missing parts to get this chatbot to run. All right, so when you look at this code, you basically see these two lines here. These are comments. It says fix this and fix this. Okay, so from this code, you can see that we are prompting the user. Then we're going to collect a number from them, going to convert it into an integer, and then we're going to start out with the EU shoe size equals to 0, and then we have a couple of else statements. If the shoe type is equal to M, meaning someone entered M for men, then we need to say that the EU, which is European shoe size, is equal to, right now it's blank, so we have to change this. So if I run this, what's your name? I'm going to say Nazar. Hello Nazar, do you wear men's or women's shoes? Type M for men and W for women. So I'm going to type M for men, hit enter. And it says, what is your US shoe size? I'm going to say 9, hit enter. And then, thanks Nazar, European shoe size is blank. Okay, so here is this line. Thanks Nazar, your European shoe size is. Now why is this blank? Well, it's blank because I did not specify what this EU underscore shoe underscore size is, because right now it's blank. All right, but the instructions tell me here that if it's a men's shoe size, then I need to add 33 to the US shoe size, which I entered, or if it's a women's shoe, then I need to add 31 to whatever was entered. So I need to modify this code here. I'm going to erase this comment. So EU shoe size is going to equal to, now notice what just happened here. Something popped up that says US shoe size plus 33. This is part of the Google Colab AI generation of code. All right, and you can see down here, it says you can start coding in a code cell or you can generate with AI. So now in Google Colab, we have built-in AI features that can help us to write code. And you can see that the AI is smart enough that it says, okay, looks like to calculate the EU shoe size, it needs to be the US shoe size plus 33. And that's correct. So it kind of read what the description was, and it's defining the code for me correctly. So I'm going to hit tab, and now it's no longer grayed out, and it's code that I can use. Technically, it's okay to use AI to help you, but if you don't know how this came about, then try to figure it out. Okay, I'm not against using AI at all to help you code, but if you don't know something and you rely on AI to do it for you, then you're not really learning. You're kind of taking a shortcut, and you're also shortchanging your education. Okay, so use AI to help you be more productive. There's nothing wrong with that, but don't let it do your work for you if you don't know it. If you do know it, then yes, let it help you to be more productive. But you have to know the material first before you can use AI. All right, so then down here, I'm going to also say for the EU shoe size, if it's a W, I'm just going to change that, erase the hard-coded value, which is nothing, and I'm going to say, oh, kind of beat me to the punch. For women's size, it is U shoe size plus 31, so that's the correct code. I'm just going to hit tab, and boom, I'm done. Now, every time you write code, you have to test it out, so let's click on play. What is your name? Let's say Nizar. Okay, let's say now I'm wear women's shoe size, and let's keep it also at 9. So 9, because it's women's shoe size, 9 plus 31, so this would be 9 plus 31 is 40, so that's correct. Now let's just verify again the men's shoe size. Okay, Nizar, men, and let's keep it 9. So 9 plus 33 is 42, so this is correct. Okay, so that's the first chatbot. Again, it's a chatbot because it's a robot that I get to interact with on a chat messages, and we go back and forth with questions and answers. Okay, so that would be the first assignment for you. Now, once you're done with this, what I want you to submit is to go up here, click on File, and then click on Download, and then download the IPy notebook. Okay, so when you click on that, it's going to download it for you, and then that's the file that you need to upload into the assignment. All right, and again, if you do have any questions, please reach out to me at any time. Okay, so that pretty much wraps up the week 3 video for us. Again, we did cover a lot of material, so if you have any questions, if you need more clarification on something, if you need help with anything, just please either email me or send a message in the public Q&A forum. Just remember, the Q&A forum is public, so anything you say will be seen by the entire class. Alright, so thank you for watching, and I'll be seeing you in class. Take care, and bye for now.